Hey everybody, so today we are continuing on in Unit 6, moving on to Chapter 8.2, talking about the Pythagorean Theorem. Hopefully you remember learning this in middle school. Okay, so Pythagorean Theorem is when you are looking at right triangles, okay, and we know that the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Or, the way you guys might have remembered learning it, a squared plus b squared equals c squared, where a and b are your legs and c is your hypotenuse. Okay, so just a little refresher how to work with the Pythagorean theorem. Okay, so here the side opposite of the right angle is always going to be hypotenuse. Okay, that is your longest side. So c equals x. So if we are working on this problem, we can say a squared plus b squared equals c squared, right? A and b are our legs. It doesn't really matter which one is which, okay? It's just the main thing is that we have c squared as our hypotenuse. Okay, so now we're going to square both of these. 225 is going to be c squared. This will give us a total of 261 being c squared, but remember we are looking for just c or our hypotenuse, so we need to take the square root. Okay, so we've been working on simplifying and reducing radicals. In this case, we want to find perfect squares. Okay, so 261 is actually 9 times 29. So when we reduce our radical, we'll get a value of c being 3 square root of 29. Okay, and then the next example, we are just looking for a leg length. So when we are given the hypotenuse, okay, we can say again a squared plus b squared equals c squared. Okay, a and b, again, it does not matter which ones are the legs. In this case, a will be our missing variable, and c squared is 11 squared. So then we will just simplify out a little bit. 81 plus 121, okay, this equals, okay, so now we'll have a squared minus 81 on both sides equals 40. Take the square root, so a, or our leg, will equal, think of your factors of 40. We have 4 times 10. We know 4 is a perfect square, so this could be 2 square root of 10. Okay, moving on. Another little thing that you may have kind of known about, but might not have gone in depth, is something called a Pythagorean triple. So a Pythagorean triple is just a set of 3 non-zero whole numbers, a, b, and c, such that a squared plus b squared equals c squared. So there are quite a few sets of common Pythagorean triples that you might see. The most common one that you most likely have seen before is a 3, 4, 5 triangle. Okay, anytime you hear something referenced as a 3, 4, 5, it's just talking about the side length. Okay, that's a Pythagorean triple. The longest side is always going to be your hypotenuse. Okay, so longest side is always hypotenuse, or c. Okay, so some other common ones you might see, a 5, 12, 13, 8, 15, 17, or a 7, 24, 25. These are all very common, and then as we go farther down this list, we look at the multiplication factor. So a 3, 4, 5 triangle doubled would be 6, 8, 10, or tripled would be a 9, 12, 15. 9, 12, 15. So again, these are just common Pythagorean triples that you would see. This is if you multiply times 2. And then this next row is these common triples, but as multiples of 3. Okay, so the key takeaway with a Pythagorean triple, if the measures of the sides of any right triangle are not whole numbers, then they will not form a Pythagorean triple. So all of your Pythagorean triples are going to be whole numbers. Okay, so let's use a Pythagorean triple to find the value of x. Okay, so we have here 15 and 12. We notice that 15 and 12 are multiples of 3. Okay, because we know 15 equals 3 times 5, and 12 equals 3 times 4. Okay, so knowing what I know about a Pythagorean triple, 4 and 5 being a leg and a hypotenuse, if we plug this into our triangle, 4 and 5, if we have a true Pythagorean triple, this would be a multiple of 3. Okay, or this would have to be 3. So let's say 3 times our multiple of 3 is 9. So this, in order to be a right triangle, would have to be a value of 9. So let's check it. Okay, so we're going to take our values, 12 squared plus 9 squared, which we determined to be this side length here, would have to equal the value of 15 squared. Okay, so we have 144 plus 81 would need to equal 225 in order for this to be a right triangle. So we have 225 equals 225. So because we have multiples of 3 as our side lengths, we do in fact have a Pythagorean triple, 9, 12, 15. Okay, and the last new little thing that we're going to cover, you may have seen this before, may not. Okay, so there's something called a Pythagorean inequality theorem. So what that means, if you have the square of the length of the longest side, okay, if it is less than the sum of the squares of the other two sides, then the triangle is going to be acute. So if c squared, your hypotenuse, is less than the sum of a squared plus b squared, then your triangle itself, ABC, is acute. Okay? And the converse, or another example, can be given if the square of the length of the longest is greater than the sum of the squares of the sides, then the triangle is going to be obtuse. Okay, so what that would look like if your c squared, if your hypotenuse is greater than a squared plus b squared, then ABC would have to be obtuse. Okay, so let's look at an example of that. Determine whether each set of numbers can be the measures of the sides of a triangle, and if so, classify the triangle as acute, right, or obtuse. Okay, so first we need to determine, 1, is it a triangle? Okay, so remember we learned about this a few units ago. So in order for it to be a triangle, the sum of two sides has to be greater than the third side. Okay, greater than third. Okay, so remember how we checked that before. We would say that in order to check, we need to add up two side lengths. So 7 plus 14, is it greater than 16? Well, 7 plus 14 is 21. That is greater than 16. Okay, and then we check that for each pair. So 14 plus 16, is that greater than 7? 30 is greater than 7. So yes, and then the last set, 16 plus 7, is that greater than 14? 23 is greater than 14, so yes. So since we have 3 check marks, all 3 pairs are greater than the third side, then we do have a triangle. So now let's check to see what kind of classification triangle we have. So classify. In order to check, we need to compare our side length, our longest side length of our hypotenuse, and figure out, is it greater than, equal to, or less than the sum of the other two sides. Okay, so our hypotenuse is always the longest side, and then we have 7 squared plus 14 squared. Okay, So when we simplify this out, we get 256 is going to equal 49 plus 196. And then when we add these two together, 49 plus 196 is 245. So when we compare 256 and 245, c squared is actually larger than the sum of a and b squared. So since c squared is greater than a squared plus b squared, our triangle is obtuse. Okay, so let's look at this last example. We're going to do the same thing. Okay, I don't know why the example's on there twice. My bad. Okay, so let's try this last one. We have 9, 40, and 41. So again, first we need to check, is it a triangle? So look at your two smallest sides first. 9 plus 40, are they greater than 41? Yes, it is. Generally, if your two smallest are larger than your third side, then it is a triangle, but let's check our other pairs as well, just for security's sake. 81 is greater than 9, and then 41 plus 9, is this greater than 40? 50 is greater than 40, so yes. So we do know it is a triangle. So now let's compare the squares of our side lengths. So c squared and then a squared and b squared, our legs. Remember, c squared is always your hypotenuse or your longest side. So 41 squared equals 9 squared plus 40 squared. Okay, so 41 squared comes out to be 1681. Okay, that's going to equal 81 plus 1600. All right, and then when we compare these final numbers, we get 1681 and 1681. These are in fact equal to each other. So we can say since c squared equals a squared plus b squared, then we know that our triangle is a right triangle. Okay? Let me know if you have any questions.